Part 4 into pressure volume rectangles or boxes and quantification of elastances. In the previous video, we described the points of end systole and end diastole at which the elastance values were maximum and minimum respectively. Each of these points are XY points created from volume and pressure data. Thus, end systolic point is from end systolic volume and end systolic pressure, and the end diastolic point from end diastolic volume and pressure. The other two corners are plotted using the same data points in a different combination. These data points can be obtained non-invasively. The volume points using a 2 or 3-dimensional volumetric assessment using echocardiography, and the diastolic pressure estimated from E by E prime or E by propagation velocity, and the end systolic pressure from aortic notch pressure or estimated from mean arterial pressure. Thus, the pressure volume loop may be deconstructed into a rectangle or box which can be plotted using non-invasively acquired data. The use of well-defined end systolic and end diastolic endpoints also helps us to quantify the systolic and diastolic performance of the heart and the vascular system. Thus, we can describe the end systolic elastance or EES, which quantifies the contractility of the left ventricle. The pumping performance of the left ventricle is well defined in terms of increase in pressure and decrease in volume. The more the contractility, more pressure is generated and more volume is ejected, resulting in an increase of end systolic pressure and decrease in end systolic volume, and vice versa. It also helps in comparison of the heart at different loading conditions, making it a preload independent indicator of contractility, which becomes important in a real-time clinical evaluation. Plotting the pressure volume rectangle also helps us to look at the arterial system. Arterial elastance, EA, is defined as end systolic pressure divided by stroke volume and is equivalent to the afterload to the left ventricle. The ratio of end systolic and arterial elastances describes the ventricle arterial matching.